Please stand. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in prayer. Contra nequitiam et insidiam diaboli, et surreptitiam. Impere Deus, supplicens te peccatum. Tuque, princes militiae celestis. Satanum, aliosque spiritus malignos. Quia interdictionem animarum ergant in mundo. Divina virtute, in infernum dissolute. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. All right, welcome back. Take out your notes, please. We're going to finish off the notes on how to handle inequalities. First, I'd like to see if somebody can handle this. Note, this is a review problem. This is not an inequality. It's a plain old, relatively dull equality equation. So how do you do that? What form is this, first of all? Somebody, it's standard form. Any recommendation for graphing standard form? There are several possible ways. How do you graph standard form? There are two main ways. There are a few others. Yeah. You can do the chubby hand method. Basically, that for the occasional person listening to my YouTube channel on India, what that means for the chubby hand method, it's a long story, which basically means finding the x-intercept and the y-intercept. So it's going to be 0, comma something, something, comma 0. Somebody tell me how to do that. Can somebody find me this first one? Yeah, good. Plug 0 for x. So what's 2 times 0? 0. And the story goes, you put your chubby hand over that thing and it's gone. Solve on your head for me. Y equals negative 4. Correct. Does that make sense? And the other one, Abby, go for it. What about this one?
It is negative 10.
Correct. Because 5 times 0, you plug it in for y to 0. Covered up. 2x equals negative 20. X is negative 10. Now we're ready to graph. 0, comma negative 4 is down here, 4 spaces from the center, in the origin. And here it's 10 spaces to the left. I had to make 10, didn't I? 6, 7, 8, 9, 10. And I'm going to mark these just so people can recognize them from a distance. And you should be able to just connect them with a solid line with arrows when you're done. Does that make sense? There is another way to do it. If you happen to remember, there are two little cheat formulas. The slope of standard form, if you remember, standard form is ax plus by equals c. Anybody remember the small formula that gives you the slope? It's very small. Yeah.
Negative a over b.
Negative a over b. That'll give you the slope. So remember the formula for the y-intercept. They're both over the same letter, perhaps. Yeah.
C over B?
C over b. Positive c over b. That should, in this case, give you negative 2 over 5. And then the y-intercept is negative 20 over 5, which is negative 4. And then you can do the slope-intercept form. Y equals negative 2/5 x plus negative 4. So you go down to negative 4 intercept, and then you rise negative 2, which is falling 2, and then go over 5, which will actually land you on the same line, just further down. So it'll give you the same graph, just a little bit further down. Does that make sense? Either way is fine with me. Whichever way gives you the correct graph, I'm happy with it. It's nice to know both. If you get caught in a dark alley somewhere and have to graph, standard. I'm sure that happens to everybody all the time. All right. How about this graph? 2x plus 5y greater than negative 20. I keep all the numbers the same. There are two new implications to this, two new things you have to consider. Name one. What's different about this than the previous graph? What will be there that was not there before? What will be different? Yeah. What's that? Dotted line, correct. There's no equals, which means it's what we call an open line. What we call dotted or dashed. What else? Yeah.
The shaded region.
Right. Anytime you have a greater than or a less than, you can have shading on one side or the other. We don't know which way, but there's going to be shading either on one side or on the other side. So let's graph this thing. Rainey, take over. What kind of dots am I going to use, first of all?
Open.
Open, good. If there's no equal sign, I'm going to use open dots. Where? What's that?
Well, on the graph.
Exactly. It's the exact same numbers, so the exact same points. But that's open dot. And then the same thing here. These spacings are not very good. So watching at home, yes, I grouped that up. Open. What kind of a line? A dotted line. Are we done? Play it. No, we need do one more thing. Like what? Shade. Exactly. How do you tell which way to shade? We're either going to go up and to the right or down to the left. Which way? How do we find out?
Plotting a point.
Correct. We're going to test a point. Test any point that's not what? Not where. There's only one type of point we should not test. Josh. For example, I would not test 0, negative 4. Why not? It's on the line, not on the border. Now, picture, this is kind of a dumb example, but most of mine are anyway. Pretend this is a fence, and you're going to paint either one side of the fence or the other side of the fence. And I know, yeah, everybody paints lawns all the time. Just bear with me. And I'm walking along the top of the fence. Okay, so either to my left I'm going to paint, or to my right I'm going to paint, I don't know. What if I test a point on the fence, just right on the fence, and it comes up true? Where do I paint? Yeah, what? Yeah.
Where the point was.
What if you tested a point right on the border?
Well, it would still be included because you know it's on the border.
Okay, it might be included. So which way would I shade?
You wouldn't know.
We wouldn't know. Does that make sense? If you test right on the fence and it comes up true, well, great, you paint the fence. But it doesn't tell you which side to shade. Does that make sense? So you have to test either one side or the other. Make sure you don't test any points that are on the border. If you can get away with it, what point is particularly nice and easy? Go. 0, 0. 0, 0 is nice. It's not, in fact, you don't have to use 0, 0. You can use 10, 10 or whatever. And if 0, 0 happens to be on the border, you have to use another point. So let's test it. Tell me how. Becca, take over. What does it mean to test?
You just plug in
Yeah, plug it into the formula. So what is it? 2 times 0 plus,
5 times 0
okay,
is
greater than negative 20. Let's see if this is actually true. What is this? 0 plus 0 is bigger than,
negative 20.
true or false? That's false. Because 0, think of temperature. They're saying 0 is warmer than 20. Actually, wait a minute, what the heck? Sorry, I followed you off the cliff. Is 0, think of temperature. Yeah, it's true. People in India, I knew that, by the way. I just completely, no, it happens to everybody, you don't worry about it. I just spaced out. So, this is true. 0 degrees is warmer than 20 below. Trust me, I've been in both. So, that's from Wisconsin. So, if this, I usually put a little X at the test point, and I indicate whether it's true or false. So tell me which way to shade. Do I shade up toward the point or away from the point? Toward the point. Shade up here, and you can use nice light lines. You don't have to go the whole thing. And that's it. That is your graph. Again, in real life, this would be solid blue. I would just take a bucket of paint and go splash. And this whole upper part would be just filled with blue. Solid dots as far as the eye can see. And on the bottom, open. No dots as far as the eye can see. Okay? I'm going to point to the graph, and you tell me whether the point I'm pointing to, no pun intended, okay, pun slightly intended, is true or false. Good. True. Here. True. True. I see a bunch of thumbs up. For people who are listening at home, and I don't hear anything. Yeah, that's why everybody's doing a mute version. Oh, I hear it. Everybody's doing thumbs down. That's fine. Here. True. Here. How about here, right on the line? It's false. Why? Why is it false?
Because it's not very well.
Yeah, it's not dot. It's not solid. Solid line means there would be a bunch of solid dots. If it's open, that means we missed it by just that much. Barely, 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 but we missed it. Does that make sense? Okay. A question in the homework might ask you, here's a graph. Does the point 10, 2 satisfy this formula? Well, what you do is 10, 2. You tell me. Would 10, 2 satisfy this thing? Yeah. And another way to prove it is plug it in, and I can pretty much guarantee you it'll be true. Have you read that? Now, let's see who remembers this form. You can use this trick with any of the 4 forms of a line that we covered. We covered 4 of them. Slope intercept, standard. What are the other 2? Yeah. Point slope and, let me know the 4th one. Starts on I. Good.
Intercept form.
Intercept form, correct. Let's try point slope. Y minus 3 is less than or equal to 2/3 parentheses x plus 1. I would like you to graph this. So, oh, this whole thing's still on. We're good. All the people in India are going to think all the math teachers in Wisconsin, Michigan are complete idiots. But, well, okay, fair. Go for it. There is something a little bit wrong with the formula. It's not quite point slope form. Sam, what's wrong with it? There's one little thing that I need to fix. Can you tell me, what is point slope form? Just give me the letters.
Y minus y1
Equals usually.
equals x parentheses.
Some before that. A letter before it, right?
A?
What?
I don't remember.
Well, what's the name of it again? Point what?
Point slope.
Point slope.
Oh,
What letter is it?
S.
Not S, but what letter is for slope? Think of like slope intercept form.
Oh, M.
Yeah, there you go. Actually, that's a good question. It should have been at, well, no, that's kind of American-centric. It's like the reason it's not S is because this was not invented in English. It was invented in French. And the word for slope is montaire or montagne, or depending on this. So it's from France. So they had to name it in French. So it's M and then parentheses what?
X plus 1.
Oh, no, in general. Y minus y1 is equal to m parentheses x. It's kind of a mirror image of that.
Minus x1.
Minus x1. So what's wrong? Other than my cups going up to you. There. wrong with this formula? There's one symbol that's not the way it should be.
Is it the x plus 1?
Yes, what should it be?
X minus 1.
It should be x minus something, but how do you change it legally? Adding a positive is the same as subtracting a
Negative.
negative. X minus negative 1. Now we're in good form. Can somebody tell me the starting point? Let me see. Megan. Close. Negative 1 comma. Right. Regular 3. Whatever's after the subtract sign. Negative 1 comma 3. So I'm going to, what kind of a dot should I use? Open or closed? Correct. Why do you say that? Yeah, the equal to means you're going to have solid dots. And then where do I go from there? Keep going. Okay. You got the starting point. Correct. Use the slope. Up to, over 3. What kind of a dot there? Another solid. And what kind of a line? Solid or dotted? Solid. Are we done? Let me see. Perfect. Are we done with this thing? No. What's left to do? Shading. Do we shade above or do we shade below? I don't know either. How do you find out? Test a point. Pick a point. 0, 0 is particularly nice usually. So let's try test 0, 0. Plug it in for me. What does it look like?
0 minus 3
Good.
is less than
Less
or
than
equal
equal
to 2 over 3 parentheses 0.
And you can use the original plus 1. Simplify that for me. What's 0 minus 3?
Negative 3.
Less than or equal to 2/3 times what? 1. What is 2/3 times 1?
2/3.
Yeah, it's 2/3. 1 times anything doesn't do anything. So what's your verdict? Well, math people. Is negative 3 actually less than or equal to 2/3? Who wants to commit? Go. Flip. Yes, it is true. So this comes up true. Which way should we shade? Toward it. So in this case, we're shading down and to the right because we're shading toward the truth. If something is true, run toward it. If something is false, run away from it. There is the moral life in one lesson from mathematics. From mathematics to the rest of the world, you're welcome. Now, questions? Okay, I told you that story. Did you tell this one? Can somebody, sounds like it's off the beaten path, it's not. Can somebody name me the 5 methods we covered of solving systems of equations? That means more than one equation at the same time. Name one. Go. Substitution. Give me another one. Elimination. Tell me another one. Yeah. Graphing. Give me another one. Yes. Kramer's rule. Give me another one. There are actually 6 of them. Austin.
Inverse matrix.
Inverse matrices. A inverse. And there's one more which we just covered. Augmented matrices. So, substitution, elimination, graphing, and then the other ones that use matrices. Kramer's rule, use determinants. Inverse matrices, and augmented matrices, using row operations on augmented matrix. So those 6, can somebody tell me how to do this? Pick any method you like, whichever one would be fastest. What do you think? Who's feeling courageous or reckless? Go. Elimination would be beautiful. What happens? Okay, so what's left? 2x is 8, so x is 4, and now plug that back in. 4 plus y is 7, so y is what? Subtract 4 from both sides, right? 3. Ta-da, done. Less than 30 seconds. Ah, those were the days. Do you remember after, one good advantage of going through those augmented matrices, especially the 3x3 brain busters, do you see how easy this seems? It's like, oh, I remember the good old days when we did elimination. Look at this is beautiful. Well, that's because you've gotten like super mathematically buff and tough. So, just, you can like break, like mathematical trees now. So, don't let it go to your head, but, be pleased at your progress. Now, what about this? For the first time, I'm giving you two inequalities at the same time. Oh dear. Let me make sure I got that. Okay. What do we do with this monster? Any idea? Yeah. Graphing. Interesting. I don't want to do graphing. Graphing is horrible. It's blah, 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 blah. Imagine somebody graphing for a while. I want to do elimination. You see how fast elimination was? It was awesome. I'm going to do elimination. I'm going to warn you. No, don't warn me nothing. I'm going to do elimination. Yep. Elimination means you add them two thingies together, and you add x and x. Yeah, it's 2x, and these cancel. This is 8. It's beautiful. And then, we have an issue. Okay. Oops. Sorry. She could be. She's back down there. She needs to go to a Oh, okay. Apparently you have an appointment. You know as much as I do. So, okay. Thank you so much. She'll be right down. I'll miss you. So, yeah. This one says greater than, this one says less than. Well, I had to do, what does put equals? Maybe. If something's bigger and something's smaller, you tell me. A big number plus a small number. Let's just say a positive number plus a negative number. What do you get as an answer? It's a semi-trick question. What do you think? What's positive plus negative? Should be easy, right? Yeah. What's that? Okay. Actually, I'm glad. I have absolutely no idea. Let me give you an example. 5 plus negative 2. Hey, I got a positive. Hey. Positive plus negative. I got a negative. It completely depends. There's no way to know just by saying I'm adding, in my mind, I'm adding a positive and a negative number. What's the answer? I have no idea. Depends how far apart they are. Depends how far negative or positive it was. There's no way to know. So is there a way to know whether it's less than or greater than? Nope. Can't do it. Elimination has failed us. Well, I still remember substitution. I don't know why I click into southern accents when I write these things. So, why not? I'll just roll with it. I don't know substitution. I get a letter by itself. I get that x by itself. I remember my old book learning smarts. I get x is less than 1 plus y, and I'm going to plug that thing in, and then the cop comes over and says, excuse me. Mathematical police, how do you do? Just to warn you, you're about to break the mathematical law. Well, I did all my steps. I entered both sides. It's supposed to be legal. Yeah, right? You were about to substitute that, weren't you, my good man? Yeah, what's it to you? Well, you were about to plug this in, weren't you? Yeah, what's the problem with that? It's not equal. So, if you substitute something less than what you're supposed to, that's called fraud. You have the right to remain silent, etc., etc., etc. So, you can't substitute unless it's equal. You can't, if somebody has a $20 bill, you can substitute 2 10s, but you cannot substitute 2 1s. That's called theft. It's a misdemeanor, I think, with $18. You could get like 20, 30 days of jail. I've not done it, by the way, but I'm just too proud. Just for the record, I do not have a criminal record, just saying. But I cannot substitute if they're not equal. Make sense? Can I do matrices? No. Matrices assume it's equal. They always assume it's equal. There's only one method that survives this whole fiasco. What was that? Graphing. The only way to solve, please write this down. The only, I'm going to underline that 3 times. The only way to solve systems, I hope this is on screen, of inequalities is to graph. Please write that down. That, by the way, is a test question. That is a quote. I will say, what is the only way to solve systems of inequalities? And I will leave a blank. And what will you write? Graphing or graph, either way. Yeah.
What if you like multiplied it by -1s by like you flip the sign?
Oh, that's sneaky. The question is, what if I multiply by -1 and I get the signs both flipped? I tried that once. That's clever. So we get both greater than. You could definitely put greater than, but this might be much more greater. That's horrible English. Think of this. 100 is greater than 1, and 2 is greater than 1. But they're both different, they're greater by different amounts. So how much will 2x be greater than the other side? We don't know. The amounts between them get lost. Once you add them together, you lose the original differences. In other words, we don't know if this is 99 apart and this is 1 apart. All I know is it's bigger and bigger. So when we get down to the bottom, you could have greater than, it does work. But we have no idea how much greater. In other words, a little piece of invisible data got lost, which would kill your answer. So unfortunately, it doesn't, well, the times in which this will work are so vanishingly small that it's not worth trying. Okay, I think there are some that do work, but they're few and far between, and they're fun, but it's kind of like finding a 5-leaf clover, has anybody ever done that? I found 4-leaf clover. I actually found a 5-leaf clover apparently when I was like 5 years old. I was 6 years old. My mom testifies to it. She taped it into my baby book and like that. It's still there. And I did not glue it on, the extra leaf or anything like that. But in other words, it's so rare that I wouldn't count on it. The only way, practically speaking, to solve systems of inequalities is to graph. Now that's bad news in the sense of our substitution and such doesn't work. But it's good news in a certain sense. Let me rewrite that. X plus y is greater than 7. X minus y is less than 1. These are actually not very bad to graph. Have you noticed these are standard form? I'm going to use Chubby hand method on these. Blank, 0, 0, blank. And I'm going to have to use a separate Chubby hand method for this one. Find the x-intercepts and the y-intercepts for both of them separately. Let's see what happens. Can somebody tell me if y is equal to 0? Oh, by the way, when you do this, pretend it's equals for a few seconds. People sometimes get confused. They say, what am I supposed to do with the greater than sign? I get x is greater than 7. Pretend it's equals just long enough to get the intercept. Because the intercept, the greater than just means it's an open dot. That's all it means. Can somebody tell me what it would be? Let me see. Abby, this top one, pretend that y is 0. What would you see? X is what? 7. Right. And again, pretend it's equals just for the sake of it, and the only other one is?
7.
Also 7. Do the other one while we're at it. Just be careful there's a negative sign. Pretend that y is negative, and you get x is what?
X equals 1.
1. How about the other one?
Would be negative 1.
Exactly. Good. Because there's a negative 1 here. If you get the x as 0, you have to divide by a negative 1 on both sides. That big one? Let me graph these things. Can somebody graph this first one for me? Let me see. Neat. How do you graph this thing? Where do I go, first of all?
So
Like
0.7.
0.7, okay. What kind of a dot there? Open. Good. And then where else? That's it. 7 comes 0. Okay, so it'll be over here. What kind of a dot? Another open dot. What kind of a line? Dash or dotted, whichever you like best. And there's one thing left to do. Shade. How do you tell which way to shade? Test a point. Let's test 0, 0 sounds good. Put a little X on the test point. Plug it in. 0 plus 0 is greater than 7. What do you think? True or false? That's false. This test point came up false. Which way are you going to shade? Away. So I'd like you to shade up and to the right. But wait, there's more. Go ahead and finish that up first. Any questions so far? So we kind of did a whirlwind graph of the first thingy. But we have another inequality. What I'd like you to do is graph that on the exact same graphing space. In other words, I want two different graphs to overlap. Sometimes they don't overlap, but that's not your fault. So Josh, take over. How do you graph this thing?
I'll shoot a 0 and a -1.
0, -1, okay. What kind of a dot?
It's going to be open.
Open, okay.
Then you go 1 times 0.
And 1 comes 0, what kind of a dot?
Open.
And then what kind of a line?
Dotted.
A dotted line. Trying to make it dark enough so you can see. And which way is shade? How do you find out?
You have to test.
Test a point. Can you use 0, 0 again?
Yes.
Yeah, as long as it's not on the border, it should be okay. Let's test 0, 0. By the way, you don't have to test 0, 0. I don't want people to think that's the only way. Plug it in.
So it'll be 0 -0.
Minus 0 is less than.
1.
What's your verdict? True or false?
False. Or true.
That's true. Because 0 is less than 1. So which way do you shade here? You shade up or shade down?
You do it up.
You shade up. You notice our test point was above? Shade toward it. Does anybody notice what just happened on the graph? Kelly, what happened?
Shading regions overlap.
Yeah. Up here, what I would like you to do on your test is darken this. I'm going to show you a shortcut also as well that saves you ink. But this region is what's called the solution region. You do not have to list solutions because there are too many. Every single point in this overlap region is a solution. Your answer is the picture. The overlap darkened picture. That's the answer. And you're done. Does that make sense? Okay. Now, it's theoretically possible that I could give you more than 2. I could give you 3 different lines that overlap. I could give you 4 or 5 or 8, God forbid. Let me show you a few weird ones that the book is particularly fond of throwing at you. The bad news is that they're weird. The good news is that they're actually very short once you get used to them. Try this. Solve. I'm going to give you 3 of them, just to see how tough you are. X is greater than or equal to 2. Y is less than 4. Then X plus Y. Let me see. Okay. X plus Y is greater than, actually, I'm going to do X minus Y is greater than -8. How do you solve this? It's horrible. Review. This is actually something I covered yesterday. Can we grab x equals 2 on a full graph? Megan, how do you do that? Like, where do you go? Like, what's your instinct say? Megan?
The dot and 2, 0.
Okay. And for the full graph, it's not just a dot, but it's a what? Think silly putty. And a line going which way? Like running which way? Vertical. It's going up and down. This is the graph of the line x equals 2. So can somebody tell me the graph of x is greater than or equal to 2? Austin. Sorry about that iPad no more.
You could, so it would be same with the line.
Correct.
You would shade to the right.
Yeah, if you can actually eyeball and see which way it's going to shade, but you can also test a point. Let's try 0, 0. This is x and this is y. You notice when you test the point, y isn't even used. Just plug in the x is 0. 0 greater than or equal to 2. True or false? Sam.
False.
False. So the test point is false, so you shade away from it. And that was kind of our instinct, because x is greater than 2, that kind of suggests to the right anyway. Same thing with this. What kind of a line would this be? Abby, what kind of a line would we use for just that? Solid or dotted? Dotted. Right, because there's no equals. Let's see if we can do this relatively quickly. X is greater than or equal to 2. We actually did that over here. I'm going to, everybody look up here though. Please draw this in your notes if you didn't already. I'm going to put a solid dot at 2 and a vertical line, but I'm not going to shade yet. Don't shade yet. If you did, don't. So, what I'm going to do, this is a little unusual. I'm going to put little guide arrows that tell me to shade to the right. I'm not going to do it yet, but those are reminder arrows. Why did I do reminder arrows? I have done problems like this before, using a pencil on paper with 5 of these things. You graph, shade, graph, shade, graph, shade. You know what's going to happen to this thing? It's going to rip through your paper by the time you're done. You're going to say, oh, there's this 5 thing that's shaded 5 times, rip. And then you have to start over, which really, really, really stinks. Trust me. It's so depressing. What I can do is put the indicator arrows so that the only thing you have to shade at the end is the final answer. You don't have to shade, 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 and then find the overlap. Find the overlap first and then lightly shade it in. Let me show you what I mean. Can anybody tell me where to go for this? It was actually from yesterday's notes. What do you have? Spencer.
How do you go to
4 on the y-axis. What kind of a dot?
Wait, sorry. Oh,
Open dot. And what kind of a line would be there? A dotted line. Running which way? Horizontal, correct. There's a horizontal line at y equals 4. And can anybody give an educated guess as to which way we're going to shade? If its formula only has one letter, you can probably do it in your head. It says y is less than. What values of y are less? Up or down?
You shade down.
Down. Do 2 little indicator arrows shading down. Ever see how these indicator arrows are working? They're just reminder arrows to say when you're going to shade. Can everybody see in their head, the dotted one is shading down and the solid one shading to the right? Does everybody see the region that's still in the running, that's still alive? You see this region here. All the other stuff is going to be blank. It's not overlapped yet. And then this thing, oh, chubby hand remembering people. Blank, 0, 0, blank, and I hate these subtractions. And somebody did that for me. For example, please. Plug in y equals 0. Just pretend it's equals. is equal to -8, correct. Oh, what's your limit? We did the wrong one. I hate to do this to you. Can I change this to +8? Would that destroy anybody's? Okay, I was nodding. Yes, it would destroy my life. I'm sorry. My bad. So, I'll do +1. Sorry, go ahead. Now that I've undone my damage. X is equal to 8. How about y?
Y is equal to -8.
-8, very good. Because you divide by -1 whole side. This should work. Otherwise, the graph would have been extremely dumb otherwise. So 3, 4, 5, 6, 7, 8. What kind of a dot? Open or closed? Open. And then the other one is 0, -8. So 1, 2, 3, 4, 5, 6, 7, 8. Another open. And then, what kind of a line? Dotted. By the way, I'm going to carry this over a little bit. Dotted, 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 dotted. Which way do you shade? How do you find out which way to shade?
You plug in a point.
Yeah, pick one.
0, 0.
0, 0 sounds good. Plug in 0, 0, what do you get?
0 is greater than.
Yeah, 0 minus 0 is greater than 8. True or false?
False.
That's false. So you just tested 0, 0. Are you going to shade toward it or away? You just came up false.
Away.
Shade away. Look at the little indicator arrows going down. Does anybody see the region that's still going to survive? I can make these a little bit longer. Is this triangle going to get shaded? No. 2 out of 3 was great. It was covering, ooh, triangle, oh darn. Left the triangle behind. Here's your solution region. It doesn't go up here, and it doesn't go to the left of here. But this whole inner region is your solution. Does that make sense? Alrighty. Your homework is 4K-2. I would like you to do the entire thing for tomorrow. Anybody not doing it? Speak now or forever hold your feet. And this is going to be one of those things where I'm going to have to hold up yours. So you're just going to get it.
Well, last time you said not first the -1, should we just do that one?
Oh, K-1. I completely forgot about that. What was the K-1? That was the,
I wasn't supposed to.
yeah, this is the exact same one I'm talking about. You have two of them?
Finish it.
Yeah, in other words, just finish it, correct. Everybody okay? So 1 through 10 is just graphing a single one, and then 1 through 11 is just doing single ones, and then 12, 13, 14, 15 are doing 2 of them at the same time. Okay? I will give you a piece of advice on number 15. No, never mind, that's actually good. Number 14, you might want to switch that top one to slope into the farm. You can tell behind it, so you have a fraction. If that doesn't bother you, it doesn't bother me. Go to it. We have about 10, 11 minutes. Go ahead and pound away at that. And we'll see what happens. Call me over if you get stuck. And I will deactivate the video for people watching at home. Click like and subscribe. And buy from our sponsors, whoever that is, probably Cheetos or something. See you later.